Welcome viewers on this new video on regression analysis. So in this video, which is on regression analysis, we will be discussing about regression analysis in a simpler way. Regression analysis has become very popular nowadays in the researches in social sciences and behavioral sciences. It has become very popular many a times whenever we are trying to understand the relationship between different sets of variables under investigation, or whenever we are trying to get the causal relationship between independent and dependent variable. We are going for this particular method. So it is very important to understand what is actually regression, or what we actually mean whenever we are talking about regression analysis. So in this present video, I will be talking about very basics of what is the meaning of, what is the idea behind performing regression analysis, what actually it is. And to understand it in better way, I will be taking certain examples, or I will be taking one practical problem on solving regression. So as I told you, in regression analysis, multiple number of variables are involved, and we basically try to see the relationship between the independent variable and the dependent variable or the predictive variable, and then we try to see if it is somehow affecting the dependent variable. So there may be number of independent variables, more than one independent variable may be there. But I will be discussing about, in this particular video, I will be discussing about the linear regression equation involving only one independent variable. In the latter part, in the next video, I will be taking two independent variable, and then we'll try how it works. So in this particular video, I will be demonstrating to you how to solve a regression equation whenever only one independent variable is involved. So in turn, whenever you understand this particular how we perform regression analysis for one independent variable, we can also understand it for two independent variable and then multiple number of independent variables. So I will be, in this particular video, I will be practically demonstrating to you how to solve a regression or linear regression model. Okay, let us see. Okay, so before going further, let us first try to understand so how correlation and regressions are related. You just try to understand. Basically, regression, the basic statistics which works behind regression is correlation only. In fact, many of the statistics, when statistics involving parametric and non-parametric population or sample or situations, basic statistics behind them is correlation only. But how regression is different from correlation is that correlation just try to give you the strength of relationship or existence of relationship between two or more than two variables. But performing regression analysis, we can establish some causal relationship. That means you can see that if there is a relationship of something called independent and dependent variable. That means if there are certain variables which is affecting the dependent variable, so we can get a causal relationship. So basically, regression also, the basic statistics behind regression is also correlation. We have to get the scatter plot, we have to get the regression line, and then only we can go for a regression analysis. But correlation is the basic statistics. So whereas correlation just gives you the direction of relationship or existence of relationship, regression is going somehow further than that one. It is trying to give you the causal relationship between the variable. So in this way they are different, or they are related with each other also. Hopefully you understood what is the relationship between correlation and regression. So in regression analysis, basically we try to get a line of fit. I think you can see here, this is the line of fit. So basically in regression, we try to get a line of it, or sometimes it is also called, or most popularly, it is also called as multiple regression equation. So this is the line representing multiple regression equation. So this line of it gives us a multiple regression equation which can be used to predict the dependent variable. So from this, you can predict the dependent variable using one or two or multiple independent variables. So this is the idea behind whenever we are doing multiple regression. So in this particular video, which is on linear regression, so the linear regression explains the relationship between independent and dependent variables by using a straight line. That's why it is called as linear regression. So whenever we are talking about regression, when there is one dependent variable and only one independent variable, that is, we are using one independent variable or predictive variable to obtain the dependent variable or to predict the dependent variable or the criterion variable, then it is called as linear regression involving one independent variable. But when there are two or more than two independent variable or predictive variable involved, then it is called as multiple linear regression. This particular video will be talking about simple linear regression involving one independent variable. So in the next video, we will be talking about linear regression using more than one independent variable. There are different other types of regression also. You can see the list. It is a logistic regression is there, polynomial regression is there, Ries regression is also there, lasso regression is also there, quantile regression is also there, Bayesian linear regression model is also there, and similarly principal component regressions, and there are many other regression models are also there. So basically, popularly or in most of the studies, we basically go for linear regression using one independent variable or more than one independent variable to predict a dependent variable. So I will be discussing here only linear regression model, which is the most popular one. So let us see and try to understand. Okay, let us understand this particular concept taking some example. Suppose we say that a particular individual socio-economic status is there, and socio-economic status is one factor or one variable which determines a student's learning outcome. So it is quite obvious. So if we are using a student's socio-economic status and by that we are predicting a particular student's learning outcome, then we are just performing linear regression using one independent variable. So this is the example of linear regression using one independent variable, one predictive variable, that is socioeconomic status, and we are trying to predict students' learning outcome, that is our criterion variable. But many of us must have that feeling that it is not only socioeconomic status, but the students' parental support is also important whenever we talk about students' learning outcome. So here we have got two independent variable. Now, if we are using socioeconomic status, one variable, and the other variable as parental support, to determine the student's learning outcome or to predict the student's learning outcome, or if you are able to construct or able to view a multiple regression equation where involving two independent variables, socioeconomic status and parental support, and as a dependent variable, if we are getting students learning outcome, then we have constructed a multiple regression situation only. So now I think you have understood what is the basic difference between linear regression using one independent variable and then linear regression using multiple independent variable. Okay, now let us see some basics of regression. So, as I already told you earlier also, it is most used technique in social and behavioral researches. Nowadays, any type of research involving number of variables, multiple variables, we are going to use we are going to perform regression to see the type of relationship, to predict the nature of relationship. Again, it tries to identify and evaluate the relationship between a dependent variable and one or more independent variable. So we have got predictor variable, that is called independent variable, or explanatory variable. So we are basically just trying to see or evaluate the relationship between certain type of variable. One category of variable is said as dependent variable, the other category is called as independent variable. So for that position also, we are going to perform regression analysis. Thirdly, this model tries to give us a multiple regression equation. So that equation is used to predict dependent variable based on independent variables or independent variables outcome. So if our model is sound enough, if you have correctly identified that model, if you have got the line of basic fit, then you will be able to predict the value of dependent variable with very less error, and there will be less regression in our prediction. In the other way, we can say there will be less regression in our prediction, and our predicted value will be the closest possible value as per the observed actual outcome. So we should try to get a model which is capable to predict the dependent variable with minimum error. And I already told you, again I'm just repeating, only when one dependent variable is there and one independent variable is there, then it is called as linear regression. When several independent variables are involved and is used to predict a dependent variable, then it is called as multiple regression. So if one variable is only there, then we are going for linear regression, and if several variable is there, then we are going for multiple regression. So let us see the simple regression model or simple regression equation using one independent variable. So it is given by this formula y equal to beta 0 plus minus beta 1 x plus minus epsilon. So what are these particular symbols represents? So here x is the independent variable. This is the independent variable, you can see. And y is the dependent variable or criterion variable. Beta 1 is the slope of the regression line. You can see this is beta 1, and beta 0 is the intercept point of the regression line and the y-axis. So when x is 0, then what is the value of y? That is represented by beta 0. And epsilon 1 is residual or error term. So this is the simple regression model using one independent variable. You can see here that this particular simple regression model, you can see this is y, that is the actual data that you are getting, and then it is beta 0 plus minus beta 1 x, that is the line of fit that you are getting, and there is always a residual term, that is the error term or that regression term from where we are deviating from the exact observed value. So we have got a line of fit. This is the line of fit, beta 0 plus minus beta 1 x. That is, this particular equation beta 0 plus minus beta 1 x will give you the predicted value of y. And there the observed data, you can see that this observed data will be not the same as beta 0 plus minus beta 1 x. There will be little bit deviation or regression from that exact data. So this exact data will be this line of fit or predicted value of y and some residual term. So basically simple regression model is working in this way. We get a line of it, and then we compare with, we try to minimize the residual term and try to get a best line of it, try to get a model which explains the observed data in the best possible way. So this is the actual theory working behind performing simple regression. Now, this is the formula for the coefficients beta 1 and beta 0. So, beta 1 is n summation of xy minus summation of x summation of y divided by n multiplied by summation of x square and the square of summation of x. And beta 0 is y mean minus beta 1 x. So we can easily understand these particular terms. N is the number of subjects or individuals. Summation of xy is the sum of the product of dependent and independent variables, because x is independent variable, y is the dependent variable. Summation of x is sum of the independent variable, summation of y is sum of dependent variable, and summation of x square sum of square of independent variable. And y mod, we already know y mod is y mean actually. So now let us understand this particular regression model or linear regression using one independent variable by taking one practical example. We will be discussing using a simple problem. Just you try to see, this is one problem. A study is conducted for 10 students to investigate the relationship between number of hours studied and the achievement score obtained. Following is the result thus obtained. Perform regression analysis to investigate any such relationship. So here we have seen there are 10 students are there, and they number of hours they have devoted for study is explained here. It is given here. The first student is giving 5 hours of study. The fourth student is giving 4.5 hours of study. And this is the achievement score they have got. So basically we have to perform regression analysis and try to get a regression equation so that we will be able to get the we will be able to predict test score based on the number of hours they have devoted for study. So let us see how we will do this one. So you can see here in this particular example, you can see here that in the first column students are there. In the second column you have got numbers of hours they have devoted for study, that is in the second column, and this is the test score. It was already there when we looked at the problem. So as we have seen that in our regression equation we require the product of x and y, that is multiplication of test score with number of hours spent on study. So we have got one column of xy, and then we have got one x square also, the square of number of hours. So we got the value summations of x is 48, summation of y is 919. So once we have got this one, we will try to see further. So we get the mean of x as equal to 4.8, because 48 is the sum here, and then we divide it by 10 number of students, we get 4.8 as mean. Then the mean of y is 919 by 10, because the summation is 919 divided by 10, 91.9. So using the previous formula which I told you of beta 1 and summation xy minus summation of x into summation of y and summation x square by summation minus summation x square. So putting the values in this particular equation, we will get beta 1 as 5.29. You can see 10 into 4462, this is summation of xy, and 48 into 919, 48 is here summation of x, 919 is summation of y, divided by n into summation x square is 240. So you can see here summation of x square is 240 here, minus 48 square. So you divide these terms and you will get 5.29. Similarly, to get the value of beta 0, we know the formula is y bar minus beta 1x. So putting the values, we can get beta 0 equal to 91.9 minus 5.29x minus 5.29 into 4.8. So we get the value of beta 0. So beta 0 is 91.9 minus 5.29 into 4.8. Substituting these values, we get beta 0 equal to 66.508. By using these values, we can see that we get a regression equation. This is the regression equation. From this we can get the line of fit. So we get that this is the predicted value. From this we can predict y based on number of hours of study. So we can estimate the test scores based on hours of study. So how we will interpret this particular equation? So we can see that when beta 0, this is the beta 0, this is beta 0, we can see, if you can follow from the equation which I told in earlier, this is beta 0. So beta 0 is 66.508, indicates marks when study hour is 0. So if this term becomes 0, if this term is not there, so this is the marks we can get, or we can get whenever the hours of study. But practically this is not the situation, that if you will not study or not open a book you will get, but in simpler terms you can understand, this is the marks, or in the interpretation terms we can say like that. Say in the second condition, what is beta 1? Beta 1 is the regression coefficient. It is called as regression coefficient because we got it as 5.29, indicates that as study hours increases by 1 hour. So if this study hour will increase by 1 hour, the marks will increase by 5.29, because if it is, suppose this hours of study is 1, then marks will be 66.508 plus 5.29 into 1, so it will be that much. But if this hours of study will become 2, then these marks will become 66.508 plus 5.29 into 2, so it will increase 2 times of 5.29. So that's why it is, it increases by 1, the marks increases by 5.29. So hopefully you have understood how we go for solving regression lines or regression equations. So we have got a regression line equation. This is the regression line equation by which we can estimate test score. So after getting the linear regression equation, or the equation by which we can predict the value of y, or the estimate the value of y, now we will proceed further to get the coefficient of determination. Means how much our line of fit is capable of predicting y with less residuals, or less committing less error. So basically we have to go for ANOVA, or analysis of variance. So let us see how we do that one. So this is our example. So we have got hours of study, which we already know what is this one, and we have got the scores. This was already there in our question. Now by using the regression equation, we can always predict y. So by using the equation, by taking the values, the help of the value of beta 0, beta 1 and x, we can predict the value of y. So we have got for x equal to 5, the predicted value is, for the value of x5, we have got predicted value 92.958. Similarly, for hours of study 4, we have got predicted value as 87.668. So this basically we are getting from this particular equation, y equal to that equation was there, this equation 66.508. I hope you remember this one, 508. and plus 5.29 into x. So using this particular equation, we are getting these values 92.958, 87.668. So this is column gives you that particular value, the predicted value of y. So after getting this value, we can see this y cap minus y mean. That means we can get the regression values. That is each y cap will be subtracted with mean of y. This is mean of y is 91.9. So this particular 1.058 will get, we have got the mean equal to 91.9. So this is the y mean value. So from y mean value 91.9, we will get this particular value. For each y cap you can get this value. This is called the extent of regression, and after getting that you can always get the square of that one, so that this particular column gives you sum of squares of regression. You can always see that this particular column gives you sum of squares of regression. And how this sum of square of regression is obtained? Each predicted value of y is subtracted from the mean. You can see here y cap minus y mean, and then it is squared. So you have got sum of square of regression, which is required for doing ANOVA. Now the next column is y minus y cap. So this particular column gives you the extent of residual. So this is the observed value of y, and this is the predicted value of y. So for each particular value of y, you can see this. You can, when you are doing you are using these two particular concept, these two 90 and 92.958. If you are subtracting this one, you will get this one. Similarly, if you go for these two, you will get this minus 2.668. So we have got the residual value of y, and if you square this one, you will get this particular column, and this particular column gives you the residual sum of a square, which is coming to 1.76.834. Now the second last column gives you the total sum of square. That means y minus y observed value and y mean value. So if you subtract each y, this is the y from the y mean, so you will get this particular value. Suppose 90 minus 91.9 is minus 1.9. Similarly, so you have got y minus y bar, and then that's why the last column gives you sum of square of total. This is the sum of square of total. So this particular value is sum of square of regression, this particular value is sum of square of residual, and this particular value is sum of square of total. So these three columns we have to obtain. Basically we have to use this predicted value of y, and then we can proceed to get all the three sum of squares. So after obtaining the sum of squares, we have got the value of sum of squares, sum of regression square, sum of residual square, and sum of total sum of square. So we can have the equation of ANOVA table. So we require sum of squares. So we have got sum of squares, and then there is column of degrees of freedom. Now the sum of squares I have already discussed. Let me discuss degrees of freedom. So the degrees of freedom, the regression degrees of freedom is the total number of independent variable involved in the study. So here we have got total number of study hours, that is only one independent variable is there. The residual sum of square is obtained by number of values that we are going to estimate. So here we are going to estimate the coefficient of number of hours, that is x coefficient, and the constant or intercept term. So we have to estimate two terms. That's why the residual degrees of freedom will be number of rows, that is n is number of observation, that n is 10 minus 2, because two values we have to estimate. So in our case it will 10 minus 2, 8 will be there. And the total degrees of freedom is given by the addition of degrees of freedom of regression and residual. So in our case, the additions, when you will add 1 plus n minus 2, will get n minus 1. So in our case it will be 10 minus 1, that is only 9. Now the next column is about mean squares. So mean square is obtained by dividing the respective sum of squares by their respective degrees of freedom. So here we have got sum of square of regression by degrees of freedom is 1 in our case. And in the second row you can see that is sum of square of residual minus n minus 2, that is in our case it is 10 minus 2, that is 8. And then we can obtain f by dividing mean of squares of regression by mean of square of residual. So let us see our question. Let us take our example to understand that one. We have got regression value, sum of square is 268.6474. Residual value was 176.0834, and then we have got total also 444.9. You can add this one and check also, it will come the same one. So we'll get the same value if we'll add this one. And you have got degrees of freedom 1, 8. So mean of square is this sum of square divided by 1. You have got mean square value as 268, same value because you are dividing it by 1. And then 176.0834 divided by 8, we have got this value. And if you will get the f value, the f value is 12.205. So what is the meaning of this f value? Or you can say, if we compare this value from the ANOVA table for 1,8 degrees of freedom, we will see that the value there is 11.26. So our value is greater than that one. We have got 12.205. So our calculated value is significant. Now this ANOVA table result we have to interpret in terms of one hypothesis, basically the null hypothesis, that there is no relationship between the independent and dependent variable. That is, our f value is not significant, or we have not able to get a line of it, or we have not able to get the regression equation. That means the coefficient of x term is 0. Then only this will happen, because if coefficient of x term will be 0, there will be no relationship between x and y. So basically we conduct this f test with the hypothesis that there is no relationship between the independent and dependent variable. The coefficient of x is 0. But if the f value is coming significant, that is, the value is significant at 0.05 level, that means the coefficient of x is not 0. There is sufficient relationship in between x and y. So we have got a successful regression equation. So the f value should be significant, then only we can proceed further and we can say that we are able to get a regression equation. Our line of it is successful. Now let us proceed to calculate the coefficient of determination, or R square. So what is this R square? R square gives you the power of the model. That means we can say that it somehow reveals that how much our model is capable of predicting y, or how much variation in y is due to variation in x. So for one independent variable, maybe for number of independent variable, we can say how much variation of that dependent variable can be explained by those set of independent variables, and the values lies between 0 and 1. So if it is closer to 1, then our model is quite powerful. That means we are able to explain a sufficient number or sufficient extent of variation in the dependent variable by our independent variable. So the formula for coefficient of determination is, you can see here, it is given by explained variation by total variation, that is regression sum of square by total sum of square. So how much our regression has explained that particular variation by total variation. So we have got the regression sum of squares, you have already seen in our example, and we have got the total sum of square SST also. So if you divide it, you will get 268.6474 divided by 444.9, that is 0.604. So we can say that 60% of the variation in the marks is explained by hours of study, and which is quite significant. If you, so this is called as coefficient of determination, that is how much variation in the dependent variable we can explain by our model, or independent variable is capable of explaining the variation in the dependent variable. After understanding the basics of regression model by taking one example, we have understood how we obtained regression equation, how this regression equation can be used to predict the value of y, and how to test that regression model by conducting ANOVA test, and then again to how to calculate the coefficient of determination. That means how much our model is good enough or is fit enough to explain the variation in the dependent variable. So now I will take one more example and we will quickly repeat the thing so that you can understand in better way. So here we have taken one example of 10 patients whose age is given and then blood pressure is also given. You can see here the age is there and then blood pressure is also there. So we can see that age is given and blood pressure is there. So age is the independent variable and blood pressure is taken as dependent variable. So this question asks that perform regression analysis to investigate the existence of any such relationship. So we will perform regression analysis. We will try to get the estimated regression equation, and then again we'll conduct ANOVA test and try to get the coefficient of determination R square value also. So let us see how we can do that one. So let us see this, how we can solve this particular question and perform regression analysis test. So we have already seen that we have got the value of x, we have got the value of y, we have to get the value of xy as it is required in our formula. When we will calculate beta 0 and beta 1, xy will be required, and then x square is also required. So we have calculated xy, multiplying each x with y, we have got xy, we have got x square. Next we can get the mean of x by dividing 490 by 10. We have got 490 here. So we have got mean of x as 49 and mean of y is 1400 divided by 1 divided by 10. So we have got mean of y equal to 140. So we have got the mean of x and y. So we will get the value of beta 1 by using this equation. So putting the values of summation of x, y, summation of x, all this value if we substitute from this particular table and this particular equations, we will get the beta 1 as 1.126108. Similarly, to get beta 0, we will substitute in this equation y bar minus beta 1 x and then x bar, and we'll get beta 0 as 84.82. So we have got the estimated test score of y, or we have got the regression equation. And this is our regression equation, y cap equal to 84.82, which is beta 0, and 1.126, which is beta 1 multiplication by age. So how to interpret that one? So we have already seen the interpretation. Beta 0 or the constant term says that 84.82 is the blood pressure when age is 0. And what is beta 1? Beta 1 signifies that as age increases by 1 year, the blood pressure increases by 1.126. So which I have explained. If everything remains constant, if age will increase by 1 year, then the blood pressure will increase by 1.126 because 84.82 is the constant term. So 1.12 times of is the blood pressure will increase. So now we will be again going to perform the ANOVA for testing the hypothesis, null hypothesis that that there is no relationship between the independent and dependent variable, and to determine the coefficient of determination. So we have got this table. This table I have already explained you. This table I have already explained. We know what is X, what is Y, blood pressure, age. We already know this one. And this is the Y predicted value, which we are obtaining by that regression equation. That recently that equation we have obtained, y equal to 84 point something plus 1.26 into age. From that equation we are getting the predicted value of y, and then we are getting the regression values. So regression value is y cap, this predicted value, minus the mean value of y, that is 140. So it will subtract 140 from all these values, all this y predicted value. So we'll get this regression. And then this is this regression sum of squares, which we have already discussed in the previous example also. So we square these terms, all these terms, if it is squared, then we will get this regression sum of square. Then to get the residual sums, we are subtracting the observed data from the predicted values. So from observed data, that is 136 minus this 134.364, we will get 1.636. Second one, 110 minus 124.23 minus 14.23. So these are giving the residual value, and then we'll get the residual sum of squares as 631.716. And then we will get the total sum of square, that is y minus y mean, y observed data minus y mean values. So we will get here, so 136 minus y mean is 140, so minus 4 minus 30, and then we'll get the total sum of square 3206. So this is mere repetition of our earlier exercise. You can rewind the video and again you can see what actually how these are correlated and how we are actually doing regression sum of squares, residual sum of square, and the total sum of square. Now we have got the equation of ANOVA table. This is the same as in the previous example. We have got the sources of variation, regression, residual, and total. We try to decrease the residual so that our regression will be less, and regression from the predicted value, whatever predicted value, will be close to the observed data. So sum of squares, this sum of squares we have already found out, regression sum of square, residual sum of square, and total sum of square. And these are the degrees of freedom. I already told that how the degrees of freedoms are obtained for regression, for residual, and for total. So this is the number of independent variable involved. This is the number of values we have to estimate, and this is the sum of these two degrees of freedom. And then we will get mean squared. So by dividing the respective sum of squares to the respective degrees of freedom, so we'll get mean squares of regression and mean square of residual. And once we divide this mean square of regression by mean square of residual, we'll get your ANOVA table, and we have to see if it is significant or not significant to test with the null hypothesis. So in our example, we have got regression. This was the value. You can see that table. And then residual is this one. And by using the same formula, we have got the mean squares, dividing it by degrees of freedom. And then we have got the F value is 32.594. And once we compare with the ANOVA table, we can see that for 1,8 degrees of freedom, it is quite significant. So we can say that our null hypothesis is rejected or not accepted, and there is sufficient relationship existing between the independent variable and dependent variable. The independent variable is able to predict the dependent variable. Now we will go to calculate the coefficient of regression plus coefficient of determination. How much the variance in the dependent variable is being explained by the independent variable. So the formula for that one is, I have already told, this is explained variance by total variance. So regression sum of squares by total sum of squares. And here we have got a quite very high value, 0.8028. So 80% of the variance in that dependent variable is explained by our independent variable, or we can say that 80% variation in blood pressure is explained by the age. And we have seen in the practical example also that how our blood pressure is very much related to our age. So in this particular video, I have explained you with in simple term what is linear regression, what are the different terms involved in linear regression, how popular it is, and its importance in conducting studies nowadays. So nowadays, many of the studies are based on regression. So in this first video, I tried to explain to you the linear regression using one variable only, one independent variable only. I gave you one problem. I tried to demonstrate using one problem how to solve linear regression, how to test, how to conduct ANOVA to see the significance of the model. And also I explained to you how to determine the coefficient of determination R square. So hopefully you have understood what are these basic terms, and you will be able to solve problems based on linear regression using one independent variable. In the coming video, I will be explaining multiple regression, and I will start explaining using two variables, two independent variables, how to solve multiple regression. So I hope you have liked this particular video. So subscribe to this channel. Thank you.